If Mount Rainier fails right now, some towns would be erased. Before emergency alerts even finish sending, people would still be driving to work. While a wall of mud, taller than buildings, races toward them at highway speed, no eruption, no explosion, no second chance. By the time you understand what is happening, the disaster is already over, and this is not a theory. It has happened before, right here. When most people imagine a volcanic disaster, they picture fire, explosions tearing a mountain apart, ash clouds rising into the stratosphere, a clear moment where everything changes. Mount Rainier does not need any of that. This volcano does not rely on pressure building up beneath the surface. It does not need magma to punch its way through solid rock. It does not need warning signs that stretch over days or weeks. It does not even need to erupt. All it needs is gravity. Mount Rainier rises more than 4,300 meters above Washington State. On clear days, it dominates the skyline of Seattle, Tacoma, and the surrounding region. It looks permanent, unmovable, like something that has always been there and always will be. To many people, it represents stability, a fixed point in the landscape, a mountain you can trust. But geologically speaking, Mount Rainier is fragile. It is an active stratovolcano, built layer by layer from lava, ash, and volcanic debris. Each eruption added new material. Each quiet period allowed that material to settle. Over thousands of years, the mountain grew taller, but not necessarily stronger. Much of what makes up Mount Rainier is loose. Much of it is poorly bonded, and much of it is held together only by balance and time. The true danger of Mount Rainier is not lava. It is not ash. It is mud. A lahar is a fast-moving mixture of water, volcanic rock, ice, and debris. It behaves like liquid concrete. Dense, heavy, relentless. Unlike lava, lahars do not cool and slow down quickly. Unlike floods, they carry enormous boulders with ease. They bulldoze everything in their path. Mount Rainier is covered by more glacial ice than any other volcano in the continental United States. Enough ice to fill dozens of large lakes. Enough ice to turn gravity into a weapon. If that ice melts rapidly, collapses, or is shaken loose, it mixes instantly with loose volcanic material on the slopes of the mountain. There is no gradual transition, no slow buildup. Once that mixture forms, gravity takes over. Lahars follow river valleys because valleys offer the easiest path downhill. They accelerate as they move. They funnel into narrow channels. They gain speed and power with every kilometer. Thousands of years ago, Mount Rainier demonstrated exactly how dangerous this process can be. Around 5,600 years ago, a massive portion of the volcano failed without warning. An entire flank collapsed. There was no major explosive eruption to announce it. What followed was one of the largest mudflows in the region's history. The Osceola mudflow traveled more than 100 kilometers from the mountain. It buried valleys. It rerouted rivers. It reshaped the entire landscape. The flat lowlands where modern cities now stand were created by that single collapse. Much of the ground beneath parts of Tacoma and surrounding communities is not natural soil. It is debris from Mount Rainier. This was not a fiery apocalypse. It was a structural failure. A mountain giving up under its own weight, and nothing about Mount Rainier makes it immune to this happening again. In fact, some conditions are worse today. Inside the volcano, hot acidic fluids circulate continuously through cracks and pores in the rock. These fluids slowly alter the internal structure of the mountain. Strong volcanic rock is chemically transformed into weak, clay-like material. This process happens quietly, invisible from the outside, impossible to notice without instruments. From a distance, Mount Rainier still looks solid, snow-covered, stable, immovable. Inside, entire sections are losing strength. Geologists have mapped large zones of hydrothermally altered rock that are already unstable. These zones are constantly being pulled downslope by gravity. They do not need an eruption to fail. The volcano does not need to wake up. It does not need a sudden surge of magma. It is already under stress. Below the mountain, that geological risk becomes human. More than 80,000 people live directly inside Mount Lahar hazard zones. Hundreds of thousands more live close enough to be affected if a major collapse occurs. Entire towns are built inside river valleys that act like natural highways for mud flows. These valleys guide lahars directly toward population centers. In some communities, the estimated warning time is less than 30 minutes. In others, less than 15. That is not evacuation time. That is reaction time. Traffic would jam almost instantly. Roads would clog. Bridges would fail or be overtaken. A lahar does not wait for instructions. It does not pause for emergency plans. It does not slow down for hesitation. The most unsettling part is how quietly this disaster could begin. Mount Rainier does not need to erupt to produce a catastrophic lahar. There may be no explosion, no towering ash plume visible from satellites, no dramatic visual signal that something is about to go wrong. The collapse could happen during heavy rainfall, during a storm, at night. Seismic signals would be subtle, easy to misinterpret. The first unmistakable warning for many people would be sound. A deep, continuous roar, like thunder that does not fade. A sound that grows louder, not quieter. By the time that sound reaches nearby communities, the flow could already be minutes away. Scientists understand this risk well. That is why Mount Rainier is one of the most heavily monitored volcanoes in the United States. Seismometers track ground movement. GPS stations measure deformation. Gas sensors analyze emissions. Monitoring can provide warnings. It cannot provide control. You cannot stabilize an entire mountain. You cannot stop gravity once failure begins. Warnings only matter if people have enough time to act, and in many realistic scenarios, time would be measured in minutes. Despite all of this, Mount Rainier is often described as dormant, inactive, safe. That word creates false comfort. Dormant does not mean dead, it means waiting. Mount Rainier has erupted multiple times in the last 10,000 years. That is recent in geological terms, but more importantly, its most destructive events were not eruptions. They were collapses, quiet disasters, predictable disasters. Disasters that are easy to ignore until it is too late. If a major lahar occurred today, it would follow known river paths. It would destroy highways, rail lines, and power infrastructure. Emergency services would be cut off. Communication would fail. This would not be a local emergency. It would be a regional disaster. Recovery would take decades. Entire communities would need to be rebuilt. Some areas might never recover at all. And the trigger could be something simple. A weakened section of the mountain finally giving way. A moment where balance is lost. Mount Rainier teaches an uncomfortable lesson. The most dangerous natural threats are not always dramatic. They do not always announce themselves with fire and explosions. Sometimes they are silent, sometimes they are patient. Sometimes they wait until people stop paying attention. Right now, Mount Rainier looks peaceful, unchanged, still, but mountains do not need to move fast to destroy everything below them. They only need to move once. And when Mount Rainier does, there will be no eruption to warn you. Only gravity, doing what it has always done. This was seismosphere. No panic, no exaggeration, only what the Earth is actually doing. If you want to understand the planet beneath your feet, subscribe.